Okay, so for this question, we have a thin piece of transparent material which is placed in the path of one of the mirrors, and it causes a phase shift between the two beams of light incident on the detector in the interferometer. We have a piece of glass with a refractive index of 1.52 and a thickness L that's placed in the path of one of the mirrors. It causes light with a wavelength of 689.2 nanometers to cause a phase difference of 8 fringes. What is the value of L? Okay, so we actually had an equation for this. When we placed a material in the path of one of the arms, we have a number of wavelengths for the material minus the number of wavelengths that would occur if the wave were just traveling in air. And this is actually going to be our number of fringes. So this is going to be our 8.00 fringes. And that equaled our 2L divided by 2L n minus 1 divided by the wavelength of light, and that is in air. So remember, because this is going to be 2L n divided by lambda, and this is just 2L divided by lambda. Okay, cool. So then we need to rearrange this and try and figure out what L is. So this is going to be, I'm just going to call this delta n for now. So we're going to end up with delta n lambda divided by 2 outside of n minus 1, and that's going to equal L. So now we just sub in everything we know. 8 by 689.2 by 10 to the minus 9 meters divided by our 2 multiplied by 1.52 minus 1. And when we do that, we get 5.302 by 10 to the minus 6 meters, and we want our answer in micrometers, so it's going to be 5.302 micrometers, and that's the answer.